Hello everyone. Welcome to the aircraft construction course. I am Zhang Qiyuan. This class allows us to continue to explore the flight control system together. The content of this issue includes the composition and principle of the auxiliary control system and the warning system. Part 1. Composition and principle of auxiliary control system. The auxiliary control system consists of three parts: a high lift device, a spoiler, and a horizontal stabilizer. The high lift device includes leading edge flaps, leading edge slats, and trailing edge flaps, which are used to increase lift, reduce takeoff and landing speed, and shorten the taxiing distance. The spoiler has deceleration and roll assist functions to improve flight safety. The horizontal stabilizer trim system is used to eliminate the unbalanced moment in the pitch direction of the aircraft and reduce the fatigue of the pilot's long-term control. Let's first look at how the high lift device works. Taking the Boeing 737 aircraft as an example, the leading edge of the wing root is the leading edge flap, also known as the Kruger flap. Distributed on the leading edge of the outer wing are leading edge slats. When the leading edge slats and leading edge flaps, also known as Kruger flaps, are opened, an airflow gap is formed, allowing the air under the wing to flow above the wing, delaying the separation of the boundary layer and increasing lift. Modern large aircraft adopt receding slot-type trailing edge flaps, which delay the separation of boundary layers by forming airflow gaps, and increase the wing area and curvature, significantly increasing lift. As can be seen from the picture on the right, the trailing edge flap is divided into three sections, leaving three gaps in the middle. The high lift device is generally only opened during takeoff and landing. Under normal conditions of the hydraulic system, the driver manipulates the lifting device to release or retract through the flap control handle of the central console. When the hydraulic system fails, the high lift device can be controlled by a spare flap control switch. Most of the trailing edge flaps of large aircraft are driven by ball screws. When the hydraulic system is normal, the rotating power of the lead screw comes from the hydraulic motor. When the hydraulic system fails, the lead screw can be driven by a motor. Hydraulic motors and motors are contained within the trailing edge flap power drive assembly PDU. Please look at the deceleration base of the aircraft in the the spoiler. Spoilers for large aircraft are usually installed on the upper surface of the wing and are driven by hydraulic actuators. When the driver controls the spoiler handle, the spoilers on both sides are opened at the same time. The air resistance increases and the aircraft decelerates. When the pilot controls the steering wheel greatly, the one-sided spoiler opens and controls the roll of the aircraft together with the aileron. Each flight of the same aircraft is loaded differently. Before takeoff, the pilot needs to adjust the angle of the horizontal stabilizer to obtain a suitable horizontal tail lift and maintain the pitch balance of the aircraft. There are two ways to control the horizontal stabilizer: trim switches and trim hand wheels. Trim switches are located on the steering wheel, and trim hand wheels are located on either side of the center console. In flight, if the electric trim loses control, the aircraft can be powered off by raising or lowering its head violently. The trailing edge of the horizontal stabilizer is fixed to a shaft, and the leading edge is installed on the screw and can be moved up and down. Under normal circumstances, the screw can be driven by a motor or a hydraulic motor, depending on the model, and can be driven manually if necessary. Part 2. Warning system. The takeoff warning system ensures that the aircraft is in a safe state before takeoff and prevents accidents caused by misconfiguration. When the aircraft is on the ground, pushing any throttle lever to the takeoff position and meeting any of the following conditions, the takeoff warning will be triggered. The speed brake handle is not in the down position, the parking brake was not released, the leading edge flap was not released, the leading edge flaps are not in the takeoff position, the horizontal stabilizer trim is not in the green area. Takeoff warning methods include horn alarm, main warning light, ACAS or ECAM text message. A stall warning system refers to a device that warns the pilot when the aircraft approaches a stall. Stall management calculation based on angle of attack. Input signals such as airspeed, flap position, slat position, and air-ground signal evaluate the flight status. If there's a risk of stall, a warning is issued by shaking the stick, sound, lights, etc., and the leading edge slats are automatically released to avoid the stall of the aircraft. This course is over. Thank you for your study. Now comes the exercise session. Students can press the pause button to think and answer. Let's start now. Have all the students answered correctly?